So in question 8b, we're given that the surface of P is an equipotential surface, E0, and we're also drawn E1 on the graph. We're told the distance from E1 to the center of the planet is 3r over 2. We're given the potential difference between these two surfaces, and we need to estimate the average gravitational field strength. We're given the radius of P as well. So we know that G is equal to minus the potential difference over the change in the distance. So we simply need to divide these two. So the distance between these two surfaces is r over 2. So G is going to be the potential difference divided by the radius, 8.56, 8.5 times 10 to the 6 over 2. This will give us 0.52 newtons per kilogram. And then in part 2, we are given that a second equipotential surface is such that the difference between E2 and E1 is 2.2 times 10 to the 6, so the same as between E1 and E0. We need to draw the equipotential line E2 on the diagram. So if we consider the difference between E2 and E0, that is going to be exactly twice that of E1. So E2 to E0 is going to be 4.4 times 10 to the 6 joules per kilogram. We know V, we know the formula for potential is simply minus Gm over R. So what we know is that the radius will have to double so that the potential is a half. So what we know is that the current distance from the center of the planet for E1 is 3r over 2. And at this potential, we have, at this line, we have 2.2 times 10 to the 6. Now we need to find out at which distance from the center will we have a potential of E2 to E0. So the difference between E2 and E0 has to be 4.4 times 10 to the 6. So the radius has to be halved, or the distance has to be there has to be a 2 here, so we need a factor of 2. The radius has to be doubled, so to say. So we get a 1/2 factor in here. So what that simply means is this is 3r over 2, so the next one has to be at 3r, so that is the same potential. So we simply draw a circle at a distance of 3r from the center.